Our second binomial denominator that we need to rationalize has two radicals. This doesn't happen quite as often as the first case, but it will show up every now and then. The conjugate there is still just those same two terms, root 5 and root 3, where the second one changes sign. So the process doesn't change, even though our denominator looks a little different than the previous example. Conjugate is still root 5 minus root 3. So in practice, we usually omit that step 2, multiplying by 1, but it's important to remember that that's why we're allowed to do step 3. You can multiply any fraction by 1, and conjugate over conjugate is the same thing as 1. Anything divided by itself is 1. So step 2 is there to remind you of why you're allowed to do step 3. Let's go ahead and do this step 3. Conjugate over conjugate. Root 5 minus root 3 over root 5 minus root 3. From the previous example, you likely remember that step 4 is where the real meat is. There's a distributive property in the numerator, multiplying that 4 by both the root 5 and the root 3. And in the denominator, we have to FOIL, because we have two terms times two terms. Keep in mind, it's a FOIL where something nice happens in the middle, but we still want to make sure we're following through with all the work, double checking that everything works out the way we expect it to. So in the numerator, we have the 4 times root 5, that's 4 root 5. We also have 4 times the negative square root of 3, which is negative 4 root 3. Positive times the negative is negative. In the denominator, this FOIL, because we have a bunch of radicals, it's going to be somewhat interesting. Let's go green for our first term. Root 5 times root 5. That's a root 25, but the square root of 25 is 5. Again, what's happening there when I multiply those two radicands together, 5 times 5 is 25, but the square root of 25 is 5. I'm going to do the inside and outside terms in red. So the outside, root 5 times negative root 3, that gives me a negative root 15. And then we also have a positive root 3 and a positive root 5. That's going to be a positive root 15. And then my last terms, root 3 and negative root 3. That is a negative root 9, but the square root of 9 is 3. So double checking that everything worked out here the way we expected to. Minus root 15 plus root 15. Those are opposites and they do cancel. So we got rid of, the radical terms. There are no more square roots in the denominator. So we can start doing a bit of cleanup. 4 root 5 minus 4 root 3, all over 5 minus 3, which is 2. So not too much worse than the previous example. We did have some extra radicals laying around, but there's still some simplifying we can do here. If you take a look at what's left behind, I have a 4, 4, and it's all divided by 2. You might notice that all of those coefficients, those whole numbers, they're all even. So one thing you could do to clean this up, notice that 4 and 4, you can factor 2 out of both of those. 4 divided by 4 is 2. The second 4 divided by 4 is also 2. And that 2 will cancel with the 2 in the denominator. This is one of those things that can help you out if you're trying to solve an equation and this comes up, or you're just looking for the simplest way to state your answer. I recognize not everybody is going to see these simplifying steps. So if you're worried about missing something like that, keep in mind we're talking like a half point for simplifying at the very end here. But it is important to always be on the lookout. Is there a nicer way I can write this? Because note that I'm going from this fraction to suddenly just having a binomial. Because those 2's cancel, I can rewrite this whole thing as 2 root 5 minus 2 root 3. And that's suddenly starting to look a whole lot like the nicer answers. I know, not as nice as Algebra 1, but some of the nicer answers from section 6.2. So be on the lookout for any simplifying that can happen. This doesn't always happen, but it is something that shows up every now and then. Stay tuned for example 3.